Welcome back to the Firebreak. I'm Steve Wolf. As you know, the Firebreak is sponsored by Team Wildfire, developing innovative technology for wildfire mitigation and suppression, using jet engines to apply mists over large areas really quickly. And I think it's going to work. So here we go. I've got with us today a fascinating guest, Xiao Fu, who is a PhD candidate at the University of Southern California, an area which is currently on fire. And Xiao brilliantly uses computer something. I'm not a computer. Uses computers, in my minimally informed way of describing it, for fire mitigation, fire prediction, fire risk reduction, and fire detection. So I will turn this over to you. You are the expert in what you're working on. But I've read several of your reports. It's actually fascinating, your idea of using different vegetative barriers to prevent fire spread and crowdsourcing fire suppression with cell phones. Tell me about what you're working on. How did you get started on that line?
Yeah, so as Steve suggested, I've worked on two major projects during the past 5 years. It started out when 2019 𝐃𝐨𝐽 took over Los Angeles in Santa Monica Mountains area. So at that point, we're thinking should we look into a more of vegetation and mitigations approaches such that we can use an alternative fuel instead of the existing vegetations that requires to be reconstructed anyway within the existing landscape. So we look into other vegetation such as especially banana, which has high water content and a lot of other features that we run a lot of simulations to validate that, okay, banana itself is a good candidate for reduce the fire risk within the existing areas. And then that leads to my second approach, which after working on the banana buffer for a little bit, I get to understand more about how the existing wildfire modeling works. And I found out that's one of the big challenges, that even though there are a lot of satellites monitoring and also a lot of the real-time monitoring, but they are either very expensive that got carried out by using drones or some sort of other plans, or satellite which just has really long latency. So the existing models that out there are not necessarily that accurate, and also a timely wildfire outskirts or perimeter per se is very important to inform firefighting agencies to allocate their resources and other things. And there are some existing research out there looking into crowdsourcing methods, but mostly within the fire detection space. So a lot of people look into we have smartphones or some other existing cameras, can we just detect wildfires? But not that much research or existing tools have looked into, can we use these devices to also map the wildfires and also just geolocate wildfires using all these devices. And some of the previous work has been explored, can we just deploy all these cameras in the wilderness, such as a lot of the very brilliant existing organizations such as 𝐟𝐨𝐫𝐿 that distributed their cameras along Pacific Northwest and especially California for wildfire detection, but they also still don't have a mapping framework for a low-cost solutions for mapping. So that's why where the second project that came in to try to figure out, can we have the smartphones that is equipped with cameras and other sensors to do a real-time mapping, which can be very important for in the scenarios where Santa Ana wind or other winds are pushing the fires propagate so fast within seconds. So those are some of the.
So let's go back for a second to the banana buffer.
Yeah.
I just want to walk out what that is. Sorry about that. So the idea of the banana buffer is that instead of letting whatever trees or shrubs or stuff is naturally out there, people want to look at vegetation but what they're looking at right now is very flammable vegetation. And it
Yeah,
sounds like what you're suggesting is that we'll replace that with a food crop, such as banana, that has very great fire resistance. I'm guessing because it has a high
yeah,
moisture content and high potassium content.
yeah, yeah. Because maybe it's one factor too.
Well, some
Yeah,
some of the retardants, right? There are retardants that use potassium as a base, so
right. Yeah,
that
I didn't think about it that way, but yeah, I guess that also makes sense. Yes.
yeah.
Yeah.
And so
For the
what
banana,
are you imagining? Like there would be like a 200, 300 meter deep perimeter around a community, or between the
yeah,
community and the wildland? Or...
yeah. So for that project, we are more running of like a proof of concept. Also, thanks specifically to my advisor, Boris Rockhaven, who is expert also in the tropical fruits. So, who sort of gave me the idea of like, okay, let's look into banana specifically. But also in Southern California, banana was like, there were a lot of banana farms per se, like back in before the water price went up. And compared to the existing vegetation in a lot of the areas, specifically like shrub or like other like shorter grass. So just like to emphasize on banana, it's not a woody vegetation, but it's a herbaceous, so it's basically a banana grass. So compared to other vegetation around the area, banana does have the benefits of fire resistance because maybe for potassium, but most likely it's because of the high water contents for the banana leaves that makes it less likely to burn. And there was a few posts like from like the recent 𝐾𝐨𝐧'𝐭 fire, like people who grew banana in their yards posted on, I can't remember at its X or other platforms that mentioned that the banana in their yard stays intact after the infrastructure got teared down by the 𝐾𝐨𝐧'𝐭 fire. So in our specific context in the experimental study, we only do it within simulators called Firesides, which is adopted by majority of the fire managers across the United States. And we did compare with like some of the existing vegetation, such as vineyard or other things that also provide economical outputs, and compare like how much more resistant it is to fire than some of the like other alternative fuel that we are trying to not only provide the fire resistant benefit, but also like economy output. It turns out that banana does stop the fire. Even the tricky part is that in our explorations, we did like 200 meters to 1200 meters width of banana buffer, which is like a few like football courts in that sense, which is like maybe it's like a not realistic case for actually growing that amount of banana. But in the simulator, we were more looking to like, can we do this as a proof of concept by adopting the banana buffer? We can slow down the fire propagations, which the high water contents play a significant role in such process. But we also want to emphasize on the economical outputs because like that's probably the most tricky part for most of the fire response or fire mitigation efforts, since maintaining the vegetation also require a lot of resources, and especially like for the water consumption, since it has high water content, so like growing banana itself might require a lot of like irrigations. So we look into something like purple water and other things to see if we can reduce the cost in such process. But the paper itself is more of a proof of concept of, hey, if you grow banana, like it can reduce the fire hazard so much more. Or if you're growing other vegetation such as vineyard. Since the initial exploration was actually done on the site of Pops Fire, which is in Sonoma County, which the wine country, and yeah.
That was very expensive for the wine growers.
Yeah.
And even more expensive
sure.
for their insurance companies, right?
Yes.
Yeah.
Yeah, insurance definitely another things for which might adopt this kind of model for like, oh, if you grow banana, maybe we can help a little bit more. And yeah.
So right now we have urban conflagrations, right? Los Angeles is burning in several locations. Um, are there good mapping tools for mapping the progress of a fire in an urban area?
I guess like a lot of people are adopting watch duty and like um I don't
It feels like that's more reporting than predicting, though.
yes for reporting for predictions. I don't see anything that's integrated into like a real life scenarios. When from my limited understanding, I probably need to update myself a little bit more with the existing tools. There are a few other companies or startups that's also looking to like using smartphones or other things to not to predict wildfire, but it's like more like detect the fire within the images. So that's what we call like fire detection. It incentivized from this like computer vision domain that's emphasized on object detection. So it's like detecting a specific object within the images. But for prediction part, I've seen a lot of works in the past couple years, numerous research looking into that specific domain that relies heavily on the satellite imagery or like the sporadic UAVs or other like aerial sensing tools. But I haven't seen anything that specifically that can achieve real-time mapping and or like having a compact prediction is really hard just because like first of all like wind itself is really hard to predict and it has a very high spatial resolutions when it comes to each individual spot. Like maybe we can predict the wind speed in general, but it's also not like spatial. If we want to predict wind to a very fine spatial temporal granularity, it's extremely
Yes.
hard. And the
Okay.
wildfires propagations heavily relies on the like a very accurate wind model. So I don't I honestly don't know like what's going to be a good measurement for a prediction model. Also, it's really hard to validate the existing prediction model since we don't have fine enough of high granularity data to evaluate that. So
So we're
that's
not there
why
yet.
one of the motivation of looking into like can we provide a finer granularity mapping tool. So maybe if this improve and with the amount of people like contributing to doing the fire monitoring, like in the future, like you essentially contribute to a more accurate prediction tool.
Okay. So tell me about the crowdsourcing use. So I've got my phone, right, and I'm not using it, and I point it out the window, and I leave my camera pointed at a fire, and I leave the app open, the Fire Loc or whatever the app is.
Yeah,
And
yeah,
then does it constantly monitor the stream from my phone to detect fires, or do I just point it at a fire once I see it?
yeah. So to
Or both?
facilitate this project, we have a few like prototypes that's might requires a little bit fine tuning when it comes to applications for, but it is one use cases if we're just using an existing phone and then if you set it up anywhere, as long as it opens this specific mobile app that we establish, then you can stream the photos to the servers that hosted the algorithms for that can do the wildfire mapping just based on images
Okay.
and other smartphone sensor data such as IMU and GPS, which provide the locations and orientation information of the images. Then we can run these algorithms for mapping, which the mapping tools integrated some of the terrain information, which is saved as digital elevation models, and also the images itself, and combine these two together and some of the other mapping algorithms that described in the details in the paper, we can accurately locate the fire objects. In our case, objects like this pixel that within the image frame that is wildfire, we can provide a location information of the wildfire within the image frame.
I
And
see.
it does have some setback. We haven't looked into how do we do it during the nighttime, there were some explorations into like infrared sensors and other sensor information that can provide very better night visions. But during the day and under a very constrained scenarios that we explore in the papers, we can accurately locate the wildfire up to 300 feet away, 3,000, sorry, 100 meters
Okay.
from the camera sources, which is like probably from the camera to the other side of the hills from the residential houses. It's probably the space that it requires. Most of the fire
I would
happens in
imagine,
very few areas.
yes. I would imagine if it's at nighttime and you're looking at a mountain and you usually see one or two houses and there's a lot of light and smoke, you don't need infrared to know that that's a fire, right?
Yes. So for that too, so maybe if maybe for the case of that, we can definitely do like a fire detection on top of like maybe the saved daytime images, so we can like cross-reference and locate the fire in the nighttime, just because like it's brighter than the rest of the images. And I just want to speak more conservatively, since we didn't run too much evaluation on top of that yet. But hopefully it will be applicable to more scenarios and more cases. If we do do you have the opportunities to push the project a little forward to a potential deployment cases?
Okay. And in what, this is just your opinion. I'm just asking, in what percentage of cases where remote detection is necessary, do those impact urban areas? So do you feel like, a city is on fire because we didn't notice a fire 200 miles away because we didn't have cameras or satellites, or do you feel like the fires that impact urban areas usually start close to those fires and we see them and we know about them?
Yeah, I wouldn't claim the recent fire in Palisades, first of all, to be like a urban fire, because it's still very far away from the real urban areas of Los Angeles. Like the places that it happens still very much within the wildland urban interface, which is like the Pacific Palisades or like even 𝐬𝐮𝐬𝐫𝐷𝐻 fire. They're both in the more vegetated area of Los Angeles. So definitely like it doesn't matter to detect like a fire 200 miles away, since it's pretty much going to be occluded anyways if there's a fire that far away. And yeah, but it's interesting though, like sometimes like no matter how far you walk away from the Hollywood sign, like you can still sometimes see the Hollywood sign like 2-3 miles away from the just from the Griffith Park, just from that area. So but definitely 200 miles would be like a little bit too much. But I think 100 meters or 300 feet is a good distance for the range required for such mapping.
Okay. And would the phones be attended? You're looking at the fire, or you're leaving the phone in your window looking out?
So it's like it's supposed to be more automatic process in our specific case. So we don't need to look into the phone specifically, since like the machine is going to do all the work after the images streaming to the server. So the human part is can be attended to other tasks, like in this specific context. And that's incentivized by some of the fire response process, which in the current state is, from my understanding, how wildfire got reported is still like each individual residents call up to the 911, or it's like a reverse 911 that the fire department will receive the phone calls, and the individuals who got impacted by the potential possible incidents is going to report, oh, I see a fire over the hill, which in the massive wildfire impact is going to be very insufficient for both the firefighting and also the residents, because it's going to be all this back and forth, and it's hard to communicate and coordinate just like all these fire incidents are happening at the same time. But with this automatic system, like the individual probably doesn't necessarily, if it does have these complex stats, both bottom up from like crowd sensing, also top down from like a firefighting resource allocation standpoint, then individual would be able to just set up the phone, and then all these fire incidents will be reported automatically, and then the firefighting agencies would be able to just looking into this aggregated map from like all these like phone collect results and allocate resources and do the fire attacks and response like accordingly.
Okay. When you say respond accordingly, I assume you mean send fire trucks with water and firefighters with axes and hoses and picks and whatever, right? So what we're seeing, it seems to me, in Los Angeles right now, is that the actual physical hardware technology that, when you say, oh, we'll tell them where the fire is and then they'll go take care of it. Well, they're going there, they're trying to take care of it. They don't have the equipment to take care of it. Like what they're doing is not stopping the fire. So is there a way to use, your computer expertise to develop better hardware for fire suppression?
Right. I guess like for like the fire, yes, it's definitely like there are a lot of bottlenecks within this process. I would say it might be like overreach for just like developing a whole new tools, but maybe the tools itself will provide better evacuations information, like, oh hey, like it's just like we're never going to get to your spot, maybe you should evacuate right now. Like that's also another information very important for residents to know, like have a better informed idea of the fire parameters. But I guess like for the hardware part, it's like very tricky since like a lot of the crowd sensing tools is in conflict with the firefighting plan. Like I don't know if you read the news in LA Times, but there was a drone that some influencer was flying, trying to capture footage, collided into this like firefighting plane, and which so I guess my concern would be like adding any of these hardwares like that's sort of communicating independently from like the firefighting folks would be challenging. Just like there are like other concerns that existing out there that might like so, but like a ground camera standpoint, I would say that the hardware part definitely requires a lot more improvements for like a more efficient responses. But I guess like from my expertise and from my previous project, like right now it's probably better just to provide a more informed ideas for both the firefighting and also like each residents like who might be impacted by fire to have a better understanding of the fires. So but I was interested in like some of the hardware, like using like I've engaged in a few like project discussions on can we use drones or other tools that's more aerial and maybe cost a little bit more to like attack a fire, like in the sense of like to just like this hardware more this kind of approach to mitigate to respond to wildfire too. But I think it's essentially going to be it's more difficult of a domain to get involved with. And I personally, like a lot of my earlier research was more on like citizen sciences in the sense of how are we going to save ourselves when the firefighting when the firefighters are already stressed out with like all the overwhelmed scenarios. So it's probably not just from like a top-down point of view, but it's more for inform each individual's like, okay, so how are we going to navigate ourselves? Like, because like there are some like communication such as reverse 911 or other things, a lot of volunteers trying to help with the process. But it's hard for me to think of any process of having like all these kind of hardwares. And I feel like the trend is going to be we have to reduce the cost of firefighting, unfortunately, and add machineries that requires more responsive and more timely manners. It's going to be somehow more expensive. And my concern is that maybe,
Yeah.
I don't know,
I
maybe
don't
they're
know. I
like
mean,
some
the
other,
idea of the machinery is that you make better use of your available manpower,
right.
right? That when an airplane comes in and drops, there's only one pilot, right? Or a small crew, right?
Yeah,
And a tremendous amount of of suppression attempts.
yes,
So that's right.
yeah,
We would say that an airplane is a better use of one firefighter flying the airplane than 100 firefighters on the ground trying to remove all those
right,
trees, right?
right. So yeah,
So
like I feel like for the mitigation part, like if we can have, yeah, I mean like a lot of the, it is kind of a tricky part, like when the resources get allocated, like such as how do we remove all these like vegetation debris and like all these like other things that can be very flammable, is also like if we have like a better monitoring systems for prior fire, it can also be contributed to this process, like as you said. So I think the next project I'm working on is like just have a little bit information, is that instead of doing the fire detection and mapping, can we have a better, more low cost like mapping mechanism for like the existing field information of the area? Since like some agencies such as Landfire and other things, they do this like vegetation surveying once every half year, or like because it's very expensive for people to surveying the land, like to survey the vegetation and transform into like a fire modeling system of the field of such areas. So if we have a more informed information of the vegetations and also the fuel like per se of the area, then we are definitely going to be able to do this mitigation a lot better. Like yes, definitely. I see what you mean by your question now. Yes, so if we have a low cost solutions for, instead of like we have to have like because we have a vast amount of land even within California, like to actually do the survey and understand where we have to remove the fuel and in the most effective way. So if we have that up to date fuel map that understand the burnability of different areas, then the firefighters and the forestry folks can, or like any other one any folks who are working within the space, then it's definitely going to be very effective to reduce the fire hazard.
I mean, yes, I'm sure you saw the video of the work for Dr. Hassan Mahmoud at the Colorado State in Fort Collins, where they had a video camera moving down the street, and the machine vision was in real time analyzing the caloric content of every plant that it drove past, and every
Oh
house and
wow!
every car. So it's driving down the street and it says, juniper 400 calories, house 100,000 calories, whatever, and you can see it's adding up the total fuel value of that block while it's driving down the block.
Right. Yeah. It's like that's definitely
Very
one
efficient.
similar applications. So that's a fascinating application. I love to take a look at the video of yes, and if it's in a very urban residential places, like the techniques or the existing research is actually relatively very mature of like mapping and like just like doing the semantic analysis, like like in our terminology of like either information want to abstract from the images itself. And I think those techniques will be very non-trivial for the future firefighting like efforts.
So what are the other things that keep you up at night?
Uh, yeah. So it's interesting. Through Wildfire, I was like looking into a lot of like California terrain for like vegetation. So I started developing like hobbies as snowboarders, and I was like interested in like avalanches research as well, because like when the fire season is severe, there aren't too many avalanches concerned. But when the fire season is not is when the fire hazard is like not as intense, like there will be high avalanches. So that's my other interest, but I don't think
I've
I'll
never
have
heard
enough.
about that, a correlation between fire activity and avalanche activity.
Oh, you might be my imagination for this correlation, but
Oh, I
I've
see.
known
Yeah, okay.
a
Well,
few
right.
folks who,
Yeah. I mean, I guess if all the trees are burned up, then you just have a big flat surface for snow to fall down or landslides.
yeah, I've
Right.
met like a couple folks who are working as responders for like ski patrol and also like firefighters, because like some of the training required are the same. So I think that's my other hobbies, which is like just like understanding vegetations within the mountain, like when it's like not burning at this point. So yes, those are my like my passions like currently. So
Okay. So do you think that like through the acquisition of big data, type systems, that you're going to find more correlations between things that we thought were unrelated? Uh,
yeah, yes, like it's
like your
fascinating.
example of fires and avalanches, is
Yes.
smog, right? Whatever.
Yes. Yeah, this is a very good point. Like, for the precipitation itself, it's really hard to understand. Like, it's not just like all these different matters, like are interconnected, but also like we are, geospatial wise, we're connected. Like, for example, like atmospheric river, like, when we look into like, how that impacted the mountains for the precipitation, and also like the wildfire. I do think, I'm very interested to see like using the big data approaches, can we understand like the climate pattern a little bit more, and how we are going to adapt based on the analysis or outcomes from like all of these analysis. So how we're going to adapt as human for based on the outcome of these analysis. So
Yeah.
I guess it's a very depressing topics to think about sometimes. And like ironically, like I'm actually currently not in Los Angeles. I I did move, but I am currently in Northern California just because I thought the wildfire would be a lot more here. But now Los Angeles is burning. It's like so like but it is stressful to have the wildfire or just like all these climate disasters at the back uh, of my mind. But it's like it is kind of an urgent topics, and it's like wherever you are, like in California, like or in the world, there are like all these climate-based disasters, not just like wildfire, floods, and like in my hometown, typhoon. Like growing up, experiencing a lot of those, and also like earthquake, and which might not be climate related, but it might still be climate related vaguely because of like the precipitation and other things for some of the riverbed. But anyway,
Yeah. No. Yeah.
so all these natural disaster can be connected itself, and also because it's like the system is like the human society as a system as a whole. If it's like overstressed to one point, it's like all these very extreme events are going to happen, then it's like we don't have, like in my mind, like in my it's like we don't have much time to to develop this like techniques or like other things to handle these like extreme events. But I guess it is like a very stressful topic to work at. um it's like, but it's like everybody can only do so much. Like we probably should convert this kind of stress into more of a motivation. From my personal experience standpoint, it's better to worry less, but putting the efforts into like coming up with more compact or like functional system that can benefit in like a longer term.
Okay. So
Yeah.
you're saying we can't worry ourselves out of this problem, but maybe we could work ourselves out of this problem.
Yes. That's yes.
Okay. Yeah. We put the work in worry. No, I don't
Yeah.
know. So you're right. It's like thinking about these things is very stressful, but the stress itself isn't constructive unless you focus that energy artistically, right, into whether it's computer analysis or, it sounds like you're really trying to understand the problem better because everyone wants to know, oh, what are we going to do about the problem? And it's, you're coming from a position, well, we can't know what to do about it until we can describe it, until we can understand it. Then we could do something about it.
Yeah, exactly.
But I guess you don't have to have you don't have to have a computer modeling of a fire to know you need to get away from the fire, right? So in that
Yes,
sense, the
100%.
computer's not going to help you evacuate, right? It's not going to, and once you evacuate, it's not going to keep you out of gridlock, right?
Yeah,
Where you have to abandon your car and run on foot. Now, maybe computers could have been used to anticipate, and I know they could have been, but what an evacuation modeling would look like, right? Because nobody anticipated that the Pacific Coast Highway would be undrivable because there were so many cars on it. So it sounds like people really are being failed, by authorities when the authorities said, okay, well, there's only 3 things you need to know. You're in a warning zone. Get ready. Go. Okay, that's not enough information, right? Where do I go? Have the traffic lights been reprogrammed for the evacuation? Are we using both sides of the road for evacuation?
Yeah, and the condition changed so drastically, like the road conditions shifted like within the seconds. And I personally drive on that highway like numerous times. That's probably the most driven highway for me when I was back in LA. So it's like looking at some footage, it was like getting real emotional, like for like how bad it is. But like there are definitely like it would definitely be very helpful, like if all those traffic cams can be integrated in some sort of evacuation plans. And I know they're like this fire is also very interesting since it happens in more developed areas in the sense of technology and resources. But I still wouldn't like complain. Complain is the wrong word. I still wouldn't blame like the authorities in such case because I think it definitely caught like all of us like kind of like, well, like we know the fire hazard is high, but it's like people has been saying that every winter, like for a few past couple years. But when it actually happens, because like all the fuel loading because of previous years' precipitations, and now it's like we didn't know it was this burnable. Like and
well, that would seem like based on the intensity of these fires, you would think you could predict that a fuel load like that would have a consequence like this. Like that doesn't require very sophisticated, AI tool to know, hey, it's been raining for 4 years. We haven't had a big fire here. There's probably a lot of fuel on the ground, and when it lights, it's going to go off like crazy. Like,
but unfortunately,
I figured that out without GPT or anything.
I do think a lot of the natural disaster studies are like, you can really not foresee everything, and it suddenly becomes very important after it actually happens. Like my line of research, it's like I've been working on it for like 5 or 6 years. Like I think the real research itself hasn't been modified too much after like 2-3 years ago, but nobody paid any attention to these to these papers for a while until like recently I got more people reaching out like and wanted to like maybe like have these things become a commodity or many other things. Suddenly just like after this incident actually happens, I wouldn't call like this is the fallacy of humanity, but it's like working on in the space of natural disaster. I don't know who say that, but it's like this is like no, but it's like there's like a saying, but it's like before it becomes a thing, like I don't think the people would actually think about allocate resources into such domain. And there's this, it's ironic.
It now, aren't they?
Yeah. So
how do you go from academic paper to practical application?
Yes, that's definitely one possible things to elaborate, probably to push forward in the next couple of years, hopefully. But it's still going to be like very ambiguous on where the project is going. So even though even if like from like academic standpoint, the purpose of publishing a papers especially in a domain. So not that many people within the two different, in the specific, like the census, like the sensor communities are interested too much in the wildfire before this event or before this paper got published. Like one of the benefits of publishing a paper is that maybe more people would be interested in working on such problems, and they would have more follow-up to have a more robust and more informed system that can contribute to the process. But I don't know, it's like stressful to think about. Like I remember somebody was telling me about this like fire chief in California back in the 70s, who was also the person who set up all the fires, and so I think it was ridiculous, like how like the top-down process works. But I think from my understanding is that the fire agency only also have so limited resources to allocate.
That's right.
So
Yeah.
maybe each individual, like sometimes like we as we can, from like a citizen science, from a top-down, bottom-up standpoint, each individual can also contribute to such process. Like just like thinking about like other tools, sensors such as purple air, which is more like cross-sensing tools, like people would monitor the fire quality. So I guess like at this point, it's like we only have so limited resources from like the people who actually from firefighters and other things. But we the citizens or like the people who reside in the process, who probably get impacted by the fire the most, can also contribute to such process. But yeah, it is definitely stressful to think about the reasoning and like other things. But I still believe in that. As a researcher, it might be really difficult to do like a real world impact, like providing a solutions, but providing tools to understanding the process and the causes and many other things when it actually happens is probably fitting my like background and expertise the most. But either it's being taken to the next steps as real deployment not requires a lot more energy and thinking towards other direction that have been taken personally. So we'll see how that goes.
We will, yeah. Have
Yeah.
you been in or attended a fire?
Yeah. So Getty Fire, I was like in LA. So 3 years ago when Riverside was or 2 years ago at this point, like 3 years, when there was a fire in Riverside, I also drove there trying to collect the data, just like using the images and like the compact system. But it was like rather difficult with the high wind and also the smoke, and we end up bail on that route. It's like very difficult to run the real-world deployments, especially in a research scenario. It's like very low resources. It's basically just me like driving the sensors out and setting it all up. And I was like very recently I was driving during the summertime. I drove past like Mount Shasta and Oregon on my way back from my summer internship going back to LA. There were a few fires in southern Oregon and northern California. I can't remember the name of fires. It's like too many names at this point. Yeah, and I'm going back to LA later this week, and kind of am convinced, like with the current wind, it probably will still not be fully contained by the time I get back, which is this weekend. So even when I started out in California, I went to UC Berkeley, 2017. That was the first semester I was ever in California, and it was, well, it is catastrophic, like apocalyptic, like just being on campus far away from the fire with all the smoke. It was rather intimidating, but like just like being around California or just like everywhere, you can feel this so intensely. And even in Seattle, like I was in Bellevue for the summer, so we went on this hike close to Lake Enchantment, even you would think Seattle, Washington, like have so much rain, like they wouldn't have any fire. But like taking that hike right next to Lake Enchantment, it's called 8 Mile Lake. They had a fire like 2-3 years ago, but you can see the trees just like recently grow out, and you can still see the burn like in the lower parts. Like that whole forest was like so different than Lake Enchantment, which is right next, which is so lush. It's like either before the fire, post fire, and after, during fire. I also was in Yosemite when they had that fire. So Pika fire, yeah, that I remember. It's like, but Yosemite does burn a lot. So there are like so many fire incidents in California. So, which is like, every year there will always be like some fires here and there, which is like, so you will come back. That's my assessment. So it's just like we want to reduce the impact to infrastructure and lives as much as we can. But it's a process of many vegetation get regenerative. Like you can probably see the conifer outside. So some of these vegetation regenerates through wildfire. So we really cannot stop it. But because of the human habitation shift and many other things, like we have to coexist with wildfire. There were a few papers talking about it. That was fascinating. So those are the papers that I was like really interested in knowing a little bit, like working towards, like, but like understanding that we have to coexist with the wildfires and trying to adapt tools and other things to mitigate the hazard. And my housemate who works in the wildfire mitigation was recently telling me these things about people living in Finland, about like there is no bad weather, there's only bad clothing. So
I read that.
Like yes. And it's like, since we are living a
they
high
haven't been
fire,
to Alaska.
I guess it's like definitely not habitable there. But I guess we just need to adapt the clothing for fires. But instead of like just completely saying that it's a bad thing. But But I believe in humanity though. So yeah. So I guess it's
I
like
can see that. That's very, very optimistic. I like that. When you saw the impact of the fires that you drove past in Southern Oregon and Northern California, and when you were on campus at USC and you knew the fires were nearby and you're smelling the smoke, how does you're experiencing those visual, visceral, seeing the reality of fire coming to life in your own eyes, how does that impact how you approach it academically?
Yeah.
Does it give you more of a sense of urgency that the academic research needs to be practically applicable more than just for the joy of theoretical learning?
Yeah, that is a good point. So I guess like for it is definitely so not just like that, but also my advisors have these like philosophy, like a research is like it's like a lot of things. If you only stay within the ivory tower, it's only if it's things only is within like a theoretical standpoint, it's all going to contribute too much value to the society. But I personally am interested in more applicable side of things. So I was like engaging a bunch of like different environmental activities like before I started this PhD program. Also, even though I was like I was doing computer science in my undergrad, and also I was like STEM my whole life, but I am very outdoorsy and I do like to spend time outside. So I guess it does provide this urgency, but it does, I saw an opportunities too, like since like it's less explored domains, and somehow like you get to spend more time outside, and also doing something that's I personally think is like rewarding and potentially can benefit other people too down the line. So I guess like this urgency more coming from like a selfish point. I do love to spend more time outside, like monitoring the vegetation and other things, but definitely seeing like a real wildfire was definitely it's like ringing the bell in your mind. Like this is a very urgent province. But I just want to quickly reflect on the 2019 Getty fires because it did happen like 6 years ago. And for 2 months after that, it wasn't urgent questions, but afterwards it becomes like some things such as COVID. Like COVID completely took over. There are like a lot of urgent real world problems to be solved. But it's like the urgency really depends on like how much it matched with my personal experience. I guess like wildfire itself is probably the one case that integrate that can integrate into my life so much better than many of the other things. It's like COVID was important, but I didn't spend much time like analyzing COVID. Also, probably just because like many reasons. So I even during the whole period of COVID, I was like still like working on like trying to understand wildfire a little bit more and seeing if there's any solutions that I can take to mitigate wildfires. But it's also because like before this, I was working like the food security space, which coming from like a food security, like understanding like how crop grows, is very similar to understanding vegetation in the forest and how it burns in some way. I guess it's more also it fits a little bit more. It fits better with my background and personal interests. But I guess like I do think there are too many catastrophic disasters that happens recently. Like just like we are going through a lot. It's really difficult to find out like what is the most urgent question to work on though. But I guess it's more important to be consistent and be targeting one directions than being a little bit scattered out. Since like
Sure.
there are
So what is
especially from like academia standpoint.
yes, right. So what if you were to do your big data hat? What was the connection between wildfire and COVID?
That is a tricky question. Yeah, like
I mean, if it's smokier outside, more people spend time indoors, so they're closer to each other.
oh,
Are they spreading germs more, or is the fact that they're not all going into work minimizing exposure and spread?
like for COVID or
Yeah, like the
yeah.
connection between COVID and wildfire.
Uh,
Would a wildfire increase or decrease COVID spread?
I guess like they do have one thing in common is that it's both like the air quality itself can impact the respiratory system in the long run.
Right. Yeah.
Impacts them.
Okay, that's good.
And COVID is also a respiratory thing. I wouldn't. It might be just like too vague of a connection between
Okay.
wildfire itself and COVID.
Well,
But
if you were
I
to,
do like this book called 𝐬𝐮𝐬𝐫𝐤𝐻, just like that line of theory. It's like about like
oh,
how
what was the book
𝐬𝐮𝐬𝐫𝐤𝐻,
called?
just like the 𝐬𝐮𝐬𝐫𝐤𝐻, or like the
Oh,
there's
guns,
like this
germs, steel. Yeah.
yeah
Yeah, very interesting. So when Dr. Hassan Mahmoud was studying wildfire progression, he linked it to disease modeling, and he
oh yeah,
found that
that too.
right that when he said if you look at fire spread the way you look at disease spread, you can actually predict fire spread with
Yeah,
much less computational,
yeah, there
headache.
are. Yeah, from a fire propagation standpoint, I can see the correlations between COVID and also wildfire because like cellular automata or like there are just tons of models out there for like the predictions or just like this kind of propagation that's spatial relevance, like the next adjacent like locations or just like the COVID requires a lot of analysis on the humans who are who have interaction. So yes, that is a good point of like what we can learn from COVID is that definitely some of these prediction models can be adopted to specifically wildfire propagations, because they are both a propagation-based model. I would say though, like for COVID, it's probably easier to have a data set of like definitely like the case for wildfire, it's way more sparse. Like it's probably higher dimensional, and there are like less data for compared to the case of COVID, since like at some points that like when everybody was doing like testing, like it's easier to flag out like to have a like the label of the data points, like either it's positive or negative. But for like the wildfire, it's still like very tricky to have accurate data to building such models. I've seen a few research starting from 2019, like when these data-driven wildfire propagation models came out, instead of using just Farsight, which is a physics-based model. It's like how using the satellite data and also like the burn, you can like simulate the wildfire parameter so much more accurate. And from that line research until now, there are like a lot more looking into like how can we just simulate wildfire a lot better. Like it all goes both for the propagation model, it does come back to the foundational, not foundational models, but more like the fundamental mathematical approaches or other data-driven methods for simulations. It will definitely benefits the whole wildfire community a lot more to have a better, more rigorous models that if people put in the effort to analysis and analyze it, there would be better wildfire simulations. I was interested in approaching that directions, but time is definitely still a concern. I would probably still look into that in the future. But like right now, I'm also interested in another case, which is like the verification of wildfire simulations. In the case of can we provide, since it doesn't matter, like it's going to be erroneous for the wildfire simulations in some way. Erroneous in the sense that it's not 100% accuracy, but we can still provide some confidence scores or like a safety bond for this is going to be the worst scenarios and this is going to be the best scenarios. And to have that vague idea for the threshold for these extreme events is probably more important than the wildfire modeling itself. Also, I'm not expert in the modeling side, which is a completely different domain than like folks who are working on like sensor systems or machine learning. So it's also tricky within the computer science field itself. Like there are like so many subdomains like you can take on to have a more applicable solutions. And all of them takes like a couple months to a year to have a compact and publishable paper. I think also like having real world problems sometimes makes this process easier, sometimes makes it more difficult, because in the earlier phase when I was submitting papers, people definitely the reviewers definitely was complaining, okay, this is way too applicable, like it sounds like wildfire is an important question, but I don't see the novelty of your methods when you're tackling such process within a algorithmic domain. So it's tricky to have both have a real world solution and have a idea that's more that's being recognized by peers within the different subfields of computer science. And even publishing papers in one field, for example, in our case, it's a census. If I want to publish paper in another field, like that's like vaguely relevant. It's going to be writing another whole stories of like trying to prove them that, okay, this is an important questions, but it's also like algorithmic sound and it's non-trivial, not just for the case I'm tackling a real world problem. So it's tricky.
Well, it's very exciting, and I love the enthusiasm that you bring to it, and very, very much looking forward to reading your next works and seeing how those get used, in real world scenarios to minimize people's misery and loss. So thank you for that. Xiao Fu, absolutely fascinating speaking with you. And
Nice chatting with
all
you,
the
Steve.
best with your continued work. And I hope that you'll, keep me informed if you have new things that you want to discuss that we can bring to our Firebreak audience. Thanks so much for joining me today.
Thank you so much for inviting me. Great to be here. Nice chatting with you, Steve.
And you as well. This has been a conversation with Xiao Fu, who's working with computers to figure out how we can have a less flammable environment and be burned less, which would be great. You've been listening to the Firebreak. I'm Steve Wolf. The Firebreak is sponsored by Team Wildfire. And until I see you next time, be well, be safe, and take care.